fiberglass sinks, steel sinks, even titanium sinks. If you drop a solid block of the raw materials used to build naval fleets into the ocean, it goes straight to the bottom. This diagram illustrates the solid mass mechanics of a sinking object. Notice how the solid polymer block drops below the H2O line. It sinks because the downward gravitational force completely overpowers any upward resistance the fluid can provide. So, if the foundational building blocks of ships are guaranteed to sink, how is it physically possible to keep a 100,000-ton steel leviathan afloat on the open ocean? Flotation depends on the volume of the hull's interior, rather than the density of the steel or fiberglass used to build it. The right panel illustrates Archimedes' Principle. Buoyant force equals the weight of displaced fluid. Notice this hollowed-out composite hull. The critical component isn't metal. It's the air cavity filling the shell. When the hull pushes down, water pushes back. That upward reactive force is buoyancy. If the boat weighs less than the exact weight of the water it displaces, it floats. If the vessel weighs more, it simply sinks. 2,000 years of naval engineering boils down to one single achievement: inventing better ways to wrap heavy metal around thin air. Because flotation depends entirely on moving water, hull geometry dictates absolutely everything about how much fluid a vessel can push out of its way. This deep hull design displaces a massive volume of water, anchoring the ship with supreme stability against waves. Conversely, a shallow hull displaces less water, reducing drag for higher speeds, but sacrificing that deep water stabilization. Whether you are steering a nimble speedboat or a colossal aircraft carrier, manipulating this exact geometric balance is the only way to control a vessel. Naval architects use hull geometry to balance these forces, determining how a ship will behave in any given sea state. This physics of displacement applies directly to the practical, everyday reality of a consumer buying a recreational boat. When you look at a standard boat spec sheet, you will see numbers for displacement, draft, and beam. Draft is the vertical distance between the waterline and the bottom of the hull, and beam is the width of the boat at its widest point. These specifications quantify how a specific hull shape will interact with the water. To find the right vessel, a buyer has to match these physical specs to the specific way they intend to experience the water. This is exactly why serious buyers and sellers connect on Ventafy, a marketplace built around these physical metrics. They provide every listing, every specification, and the granular data you need to make an informed purchasing decision. Understanding the spec sheet is understanding the science of the boat. Hit the link in the bio to find your perfect geometric match on Ventafy.
Ventafy.
Link in the bio.